In this episode, we move into a topic that becomes very real the moment an organization loses the systems, services, or technology it depends on to keep working. Designing your disaster recovery plan, DRP, is about deciding ahead of time how the organization will restore technology and supporting capabilities after a serious disruption, instead of trying to invent a response while the pressure is rising and the business is already hurting. For someone new to this material, it helps to think of the DRP as the part of resilience planning that focuses on getting critical technology and related resources back into a usable state after something major goes wrong. That may be a cyber attack, hardware failure, site outage, cloud service disruption, natural event, or human error that interrupts important systems. In the Certified Information Security Manager (CISM) mindset, the DRP is not a technical document that belongs only to engineers. It is a management tool that helps the business recover in a disciplined way when technology disruption threatens operations, customers, and trust. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A helpful place to begin is with the difference between continuity and recovery, because beginners often blend those ideas together. A business continuity plan, BCP, is about how the organization keeps essential business functions going during disruption, even if that means temporary workarounds, alternate methods, or reduced service levels. A DRP is more specifically about restoring the technology, infrastructure, data, and related capabilities that support those business functions. In simple terms, the BCP answers how the business keeps operating, while the DRP answers how the underlying technical environment is brought back in a controlled and prioritized way. These plans are closely connected, but they are not identical, and that distinction matters because technology recovery priorities should support business needs rather than exist in isolation. A server, application, or database is not recovered just because it is visible or expensive. It is recovered according to the role it plays in supporting the functions the business must protect first. That leads directly to the next core point, which is that a strong DRP begins with business understanding rather than with a list of hardware or software. If an organization starts by recovering whichever systems seem most familiar, most complicated, or most complained about, it may waste precious time while more important business functions remain down. Good plan design starts with the results of the Business Impact Analysis, BIA, because the BIA helps the organization understand which business functions are most critical, how quickly disruption becomes unacceptable, and what supporting systems those functions depend on. Once that business view is clear, recovery planning becomes more disciplined. Instead of saying everything is urgent, leaders can identify which systems, data sets, network paths, identity services, communications tools, and external connections need recovery first to support the most important business outcomes. Designing the DRP, therefore, means translating business criticality into technical recovery priorities, which is one of the most important planning steps in the entire process. Another foundational design decision is scope. The organization has to decide what the DRP covers and what assumptions it is built around, because a vague recovery plan becomes much harder to use when the disruption is already underway. Scope includes the systems, applications, data, infrastructure, facilities, cloud services, communications capabilities, and vendor dependencies that fall under the recovery effort. It also includes deciding whether the plan addresses a single site, multiple locations, on-premises technology, hosted services, or some combination of all of these. This matters because different environments fail differently and recover differently. A plan for restoring a local server room is not the same as a plan for recovering a cloud-based application environment with multiple outside providers and distributed users. Clear scope also helps avoid a common failure where critical dependencies sit outside the formal recovery plan because someone assumed another group was handling them. Good DRP design makes the boundaries visible so that important components do not disappear into ambiguity. Once scope is clear, recovery objectives become central to the design. Two ideas appear often here because they help translate business need into technical targets. Recovery time objective, RTO, refers to how quickly a system or service needs to be restored after disruption before the interruption becomes too damaging for the business. Recovery point objective, RPO, refers to how much data loss, measured in time, the organization can tolerate. These are management decisions supported by technical reality, not just technical preferences. A system that supports revenue, customer safety, regulated reporting, or essential identity services may need a shorter RTO than a less time-sensitive internal function. A database with frequent critical transactions may need a tighter RPO than a system where a few hours of lost updates can be recreated without major harm. Designing the DRP means selecting recovery objectives that reflect actual business tolerance and then planning recovery methods that can realistically meet those expectations. A plan becomes much stronger when it includes careful dependency mapping, because critical technology rarely stands alone. An application may look recoverable on paper until the organization realizes it depends on identity services, network connectivity, certificate management, cloud storage, vendor support, domain services, security monitoring, and a database located in another environment. If those supporting pieces are not restored in the right order or are not part of the same recovery picture, the main application may still remain unusable even after apparent recovery work begins. This is one reason disaster recovery planning can become more complex than beginners first expect. The real recovery target is not always a single system. It is often a chain of interdependent services that all need enough restoration to support the business function that depends on them. Strong DRP design therefore maps not only major systems, but also the surrounding pieces that make those systems operational. That dependency awareness prevents the organization from mistaking partial restoration for actual recovery. Recovery strategies sit at the heart of the DRP because this is where the organization decides how restoration will really happen. A strategy might involve restoring from backups, activating alternate infrastructure, rebuilding systems from known good images, shifting work to another site, relying on cloud failover arrangements, using secondary communications paths, or temporarily running on reduced capacity while core services are brought back. The right strategy depends on the importance of the system, the acceptable downtime, the acceptable data loss, the cost the organization is willing to bear, and the complexity of maintaining the recovery capability over time. Beginners sometimes imagine the best strategy is always the fastest or most expensive one, but effective planning is usually about matching the recovery approach to the criticality of the service. Some systems justify highly resilient recovery options because the business impact of delay is severe. Other systems can tolerate slower restoration if the organization has acceptable workarounds or if the cost of faster recovery would not make practical sense. Data recovery deserves special attention because many organizations discover too late that getting a system back online is not the same as getting trustworthy data back into that system. A DRP should therefore address not only infrastructure restoration, but also how data will be protected, restored, validated, and made available in a way that supports resumed operations. Backup design, retention logic, restoration testing, sequencing of data recovery, and verification of integrity all matter here. If the organization restores systems quickly but brings back incomplete, corrupted, outdated, or unverified data, the business may still be unable to operate safely or confidently. This is especially important in cyber events such as ransomware, where the question is not just what can be restored, but what can be restored without reintroducing compromise or destroying confidence in the recovery effort. Good DRP design treats data as a core recovery concern rather than as a secondary detail that follows after the servers, storage, or platforms appear operational again. Roles and responsibilities must also be designed with care because recovery work often crosses multiple teams that may each assume someone else is leading. The DRP should define who coordinates recovery, who makes decisions about priorities, who handles infrastructure restoration, who supports applications, who validates business readiness, who communicates with leadership, and who engages vendors or outside providers when recovery depends on them. This clarity matters because time disappears quickly during a serious outage, and unclear authority can produce duplicated effort missed steps, or delays in escalating problems. A mature plan also recognizes that recovery is not purely a technical matter. Business owners, communications leaders, continuity coordinators, security personnel, and executive decision-makers may all need defined roles depending on the scale of the event. Strong design also considers backup responsibility in case key individuals are unavailable. A DRP becomes much more dependable when it reflects how the organization actually works under pressure rather than assuming ideal staffing and perfect availability. Communication planning is equally important because disaster recovery involves more than technical restoration. People need to know what happened, what is being restored, what remains unavailable, how decisions are being prioritized, and when they can safely depend on recovered services again. The DRP should explain how technical teams communicate among themselves, how leaders receive status updates, how business owners are informed about recovery progress, and how vendors or other outside parties are engaged when necessary. Clear communication reduces the risk of business units acting on incomplete assumptions, restarting work too early, or making separate decisions based on inconsistent information. It also helps leadership understand whether recovery is following plan or whether strategic choices are needed because the disruption is more severe than originally expected. Good communication design does not require endless messaging. It requires disciplined, timely, audience-aware reporting that helps the recovery effort stay coordinated instead of becoming fragmented across teams that are all under pressure and all seeing only part of the picture. A strong DRP also includes decision points around validation, because recovery is not finished when systems merely power on or become reachable again. The organization needs a way to decide whether restored systems are actually usable, trustworthy, and aligned with business needs before normal operations fully resume. This means the plan should consider how recovery success is confirmed, who performs that confirmation, what minimum conditions must be met, and how the organization handles cases where a system appears technically available but is not yet fit for real production use. Validation may include checking data integrity, access control operation, application functionality, connectivity, monitoring, and the ability of users or supporting teams to perform essential tasks. This stage matters because premature return to service can create new disruption or hide lingering weakness. Good DRP design recognizes that restoration and business readiness are related but not identical. Recovery should therefore include a careful handoff from technical restoration to business confirmation rather than assuming that technical activity alone defines success. Vendor and third-party dependence must be built into the plan honestly, because many modern recovery efforts cannot succeed without outside support. Cloud providers, software vendors, telecommunications carriers, managed service firms, data center operators, identity providers, and hardware support partners may all play central roles during restoration. If the DRP ignores these dependencies, the organization may discover during crisis that it lacks the right contacts, service expectations, escalation paths, or contract awareness needed to move quickly. A well-designed plan identifies where outside support is essential, what assumptions exist about their availability, how to reach them, and what limitations may affect the recovery timeline. This is especially important because a major disruption may affect the vendor too, or may affect many customers at once, reducing the speed or attention the vendor can provide. Strong DRP design does not assume outside providers will automatically solve every problem. It plans for the reality that external support may be necessary, constrained, delayed, or partially unavailable at the exact moment it matters most. Testing is one of the clearest signs of whether a DRP is operationally meaningful or just administratively complete. A recovery plan that has never been tested may still contain hidden gaps in sequencing, dependency assumptions, communications, staffing, vendor support, or data restoration that only appear when people try to follow the plan in conditions that resemble real disruption. Exercises, walkthroughs, tabletop scenarios, and restoration tests help uncover those weaknesses before an actual event raises the cost of discovering them. For beginners, the important lesson is that testing is not an insult to the plan. It is part of making the plan trustworthy. It shows where objectives are realistic, where they are too optimistic, where instructions are unclear, and whether the organization can really meet the RTO and RPO values it has declared. Strong DRP design assumes from the beginning that testing will reveal needed improvements, and it builds that learning loop into the life of the plan rather than treating testing as an optional extra. Documentation quality matters too, because disaster recovery plans are often used under stressful conditions when people need clarity more than completeness for its own sake. The DRP should be organized in a way that helps responders find responsibilities, system priorities, recovery sequences, key contacts, dependencies, and escalation paths without wading through unnecessary explanation. It should be detailed enough to guide coordinated action, but not so overloaded that it becomes difficult to use when time is short. The document should also reflect the real environment, not a copied template filled with generic statements that sound mature but do not match actual systems, staffing, or vendor relationships. Version control, review ownership, update triggers, and storage location all matter because an outdated recovery document can create false confidence at the worst possible time. A good DRP is not simply comprehensive. It is usable, current, and designed for practical action under pressure. Common design mistakes are worth recognizing because they explain why recovery plans often disappoint organizations that believe they were ready. One frequent mistake is designing the plan around technology alone without grounding recovery priorities in business impact. Another is setting aggressive RTO or RPO values that sound impressive but are not supported by actual recovery capability, staffing, or budget. Some plans ignore hidden dependencies and therefore overestimate how quickly a system can be restored into a genuinely usable state. Others fail to define roles clearly, leaving recovery coordination uncertain precisely when decision speed matters most. There is also a tendency to assume backups equal recovery, even though restoration, validation, integrity, and sequencing all affect whether the business can truly resume operations. Strong design avoids these traps by staying business-aligned, realistic, tested, and honest about what the organization can actually recover and how quickly it can do so under difficult conditions. As we close, the central lesson is that designing your disaster recovery plan is really about deciding in advance how technology restoration will support business survival when disruption becomes severe enough to interrupt essential operations. A strong DRP begins with business priorities, defines scope clearly, sets realistic recovery objectives, maps dependencies, chooses sensible strategies, protects data recovery, assigns roles, supports communication, includes validation, accounts for vendors, and prepares for testing and revision over time. It helps the organization recover with more discipline and less confusion because key choices have already been thought through before the outage, attack, or disaster occurs. For a new CISM learner, this topic matters because good recovery is not a matter of luck or heroic improvisation. It is the result of careful design that links business need to technical restoration in a way the organization can actually execute. When that design work is done well, the DRP becomes a practical source of resilience instead of just a document people hope they will never need.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.